Okay, well, thanks for coming along to the Lunch and Learn today. I just have a few slides to run through, and then I'll hand over to our keynote speaker today, and then we'll have a discussion. So if you've got any questions, save them for this discussion session. So I want to say a big thanks to Siemens today for sponsoring our webinar. So we have our main event on the 29th of September, and this is a bit of a taster to hopefully generate interest in the main event. I just wanted to, if you're interested in registering for the webinar on the 29th, that's an afternoon webinar, and you'll hear about everything in much more detail that day. You can scan this QR code, that will take you directly to the page to learn more about the full-length webinar, and I'll show that again at the end. To Adam Cartwright, who's going to be talking about how to monetize your existing sensor data and digitalization. Adam Cartwright is head of Internet of Things for Siemens UK. I have to come out of this again.
So hi everybody, pleasure to meet you. Just while I'm waiting for my screen to come up, hopefully you can all see that now.
Yes, Adam, we can see it.
Hooray, okay, brilliant, thank you. So just to introduce myself very briefly, as Rosa said, I'm head of Internet of Things for Siemens UK. Before this, I was head of open innovation for Siemens, and that meant across our different UK businesses, and that's everything from manufacturing trains, wind turbines, gas turbines, MRI scanners, all the automation and factory equipment, as well as our sensor portfolio. Building management systems. It's about 15,000 people in the UK. My job was to help coordinate the different innovation activities of those businesses. And to do that, we had just under 200 collaborations with universities and shed loads of different collaborative projects between customers and our supply chain. It was great fun, really, really interesting. What I love about this is the chance to actually be involved end to end in making it happen. So you can only watch and other people have so much fun before you want to get involved yourself after a while, can't you? But one of the trends that clearly came across in all those different sectors that I was involved in is moving into a systems level view of looking at any operation. And that's spanning from organizational silos within a business to looking outside of the business, down into the supply chain, outside of the business into the customer or user base, as well as then kind of horizontally into an innovation ecosystem. And the first thing I'd point out, and this is kind of going to be the theme throughout the things that I'll share today, is that quite rightly in water, and this has been an evolving view, it's not a new idea, but it's now starting to become real, is to see the whole water network as an interconnected system that can, and many say should be, optimized at a system level. Now, in various discussions in this group elsewhere, we know that there's a large number of challenges for that, but the direction of travel becomes clear. And if we think about this from a SWIG perspective, and for many of us here who come from a hardware background, there's so many new interactions that are all starting to come together as we look at this kind of quite exciting world that's on the horizon. Clearly, there's that operational technology layer from those most basic sensors through to kind of automation at site or enterprise level. And then it's this new interface between the IT world, and had an interesting conversation with somebody from a large IT company. And they were talking about an Internet of Things project, which is obviously my world now, and saying, and you know, they've put aside 18 months for this. And I don't know why. We can put something together far quicker than 18 months. But actually, then when we talked about the time it would take to go out to site, survey the site, install things, ensure it's validated, working properly, giving yourself a baseline, and then you're ready to go. Actually, 18 months for this particular project started to make a lot more sense. And it's this interaction between the different cultures and approaches of IT and OT that's really interesting. And what's also different is that if you look outside the technology stack, it's also the difference in cultures and processes and skill sets as those who actually involved in the operational side of the business and the customer side of the business come together. I suppose what I'm trying to say here is that while we're here talking about sensors, it's very much sensors as the foundation and bedrock within a larger organizational transformation that's talking about our physical networks of systems. So the water company in the UK that's been most vocal in talking about systems is obviously United Utilities, and I'm sure many of you will have seen the recent kind of RFP, kind of ITT that went out in the market recently with a market value of up to £270 million, specifically looking at wastewater. So while we're not going to go into any of the details in that, I think what that does is takes it beyond talking about a direction of travel and also look into something now that actually is wanting to be implemented by water companies. And that means actually we do need to understand what some of those challenges are with this. So this is a presentation, just an example one from UU, from the work I've done with pretty much every water company here in the UK. There's variations in this theme in all water companies, but that sense about how you go from facilities to area to the different relationships to looking at that system level, that level of thinking in there is with everybody. And what I'd like to do in this session is just unpack that a little bit, draw on a few specific examples and challenges, and then ask a question that we can discuss around the challenges that you've experienced and help that be some kind of food for thought that can go into the session we have on the 29th, and then also really signpost as to how this is why we've structured the session on the 29th in the way that we have. So first of all, while there's a lot of very exciting talk around the leading edge of technologies in the IT world, blockchain is further down in the pit of dissolution in the hype curve, but there's always something new coming around the corner. The foundation from anything that's looking at a physical system is actually the ability to take a sensor reading, be that from a satellite, or more likely in the world of water from a physical sensor installed somewhere in the network, and bring that data into some kind of system to allow you to do your analysis. And I'd like to just draw out four. As I said, I'd be interested at others that you might prioritize as being on top of this. And then maybe give an example about how we've looked to address those challenges in a way. When everything does become connected, and here we're specifically thinking about sensors and what sensor we might choose and why. When everything's connected, suddenly there's far more stakeholders that are involved. This is something that's always been the case. But now what we're seeing as someone who supplies automation equipment as well as sensors is that actually in many water companies, the specifications and demands on those are becoming more stringent as people think more intelligently about how they meet multiple purposes from a single sensor. Also, if the sensing data becomes the bedrock for systems level decisions, the quality of that data becomes ever more important. And for those of you who are here from water companies, you will know in a very real way that actually maintaining data quality, maintaining at the right resolution and the right availability is a genuine challenge. And our view is that actually we're likely to need a step change in the quality of the data that's provided. Otherwise, the systems level optimization will actually go quite horribly wrong. The third one is a very practical one. If you recognize actually there's multiple stakeholder needs and actually there's challenges around data quality, that might mean you have budget challenges because you want to actually explore things in different ways or put in something that might be a higher specification sensor than you would normally. And the budget holders are often spread across multiple organization silos that have an interest in this. Multiple ODIs can be traced all the way back down from the system layer through the layers back down to a couple of different sensor points. And a very practical point and a non-technical point is then how you engage those multiple budget holders. And this final one here then is around compounded risk. So from work that done across multiple different systems that Siemens has done in particular in energy systems, there's a challenge of compounded risk about how one risk somewhere when interfaced with another risk actually with the level of uncertainty bands around those, means you have to understand those uncertainty bands and what you go for in the middle. And if you make a few bad calls around those, suddenly you're introducing far more risk than you should, or far less risk than you should. And actually, I think there's something here around the level of confidence that you have in your sensor data that can actually have a major driver on that. And I'd be interested in people's thoughts on this. So I want to just, touch now on this next point, that there are substantive issues in the temporal and spatial resolution. So do we have enough sensors in the right place? And are they sending data frequently enough to be able to give us the analysis we need if we're talking about a systems level analysis? Is the data quality good enough? And are we getting the data frequently enough? And in here, there's questions not just to do with the sensors, but also the RTUs and how frequently we're getting those. And here, I suppose, 7 points that we'd raise as kind of top tips and recommendations around the consideration of addressing these challenges. The first one, as we say, is ensuring that, and then this is, I suppose, from our sensor, IoT and automation supplier perspective, is please speak to us about what are the multiple use cases that potentially need to be met for any particular sensor need. Help us understand the multiple regulatory requirements that fit around those different use cases so that we can ensure we then get best value from every sensor point that's maintained in there. If we're looking at increased data transparency and we're looking at reducing OPEX, particularly from maintenance of these installed sensors, how do we ensure that we're able to understand the sensor health so that we're able to optimize then not just the performance of the system, but our maintenance actions? When it comes to data quality, we'd encourage you to look at a combination of data science-driven approaches that look at structures and features within the data, as well as measured variables taken directly from the sensor that allow you to then cross-check those and validate what the likely root cause of any kind of data quality issue might be. All those factors all lead you together into that maintenance cost v capital cost consideration. And that's where the sense of actually, I want a more expensive sensor because I need to ensure my maintenance cost is lower, or actually I can go for a cheaper sensor because the maintenance needs are going to be very low for this technology of sensor or for the specific use that I've got for it. And I think that's one of those things where we'd really welcome a richer dialogue to understand what makes most sense in that area. And finally, before I give an example and hand over to some questions, a trend I think highlighted by the Storm Overflows Task Force is there's going to be a need for increasing transparency, particularly in anything where in the wastewater network we're interfacing with leisure behavior and people's views around rivers and watercourses. That's going to get even stronger. And how can we ensure that the data we provide, all the stakeholders within our business are going to be happy to share it? Because that drive for transparency is going to increase. And this one slipped to the bottom, and I don't think that's a specific example for level around. And I think we could summarize that as how do you try and get extra add-on capabilities within a sensor? So, for example, a level sensor being able to perform a volumetric calculation in a 32-point table or something like that. So, I just want to give a practical example now of how we have done this with a water company and a Siemens kind of in collaboration to touch on multiple of these points. And do that using the example of an application we call Blockage Predictor. And this is the winner of, with Yorkshire Water, the Data and AI Project of the Year from this year's Water Industry Awards, which I'm quite excited about and not bored of shouting about either. So what this does is looks at abnormal operation and normal operation. So immediately when we're thinking about the multiple use cases, this is how can we support pollution analysts and event duration monitoring, for example. So we have an AI feature here, which is all about finding abnormalities within the performance of the network. And in this case, on 21,000 days of data, the University of Sheffield we found 9 in 10, so that's great. Reduce the number of false alarms that you might see from monitoring your network. In this case, again, the University of Sheffield found 3%. And that then allows you to have this benefit of knowing when and where to send your operations teams to ensure they're actually spending time fixing genuine issues when they're at site. So that's all around abnormal operation. But equally, if you're going to be receiving that data from the network, how can you then also use that at relevant locations to enhance your event duration monitoring? So in this case, we've looked to use the same sensor to automatically count spills or count overflows, then use 1224 counting to integrate those into spills. So you can then just click a button and your Environment Agency reporting is completed with your number of 1224 counted spills for those assets. You then automatically flag up when something's in spill, which actually coincidentally adds a lot of value to the pollution analysts as well. And you're then able to have a whole load of data quality checkers, which can be flagged to say if you've got an issue. Finally, and I think this is the end-to-end piece of the story, how can you, and this is one of those things that we can do as a sensor supplier, when you install and configure that sensor with an application, with a Bluetooth app, at the same time you automatically onboard that same sensor into the analytic app as well. So in this way, you're touching on multiple use cases, multiple stakeholders. And it all comes from a single level data, level sensor installed in the network, and that data being brought into the cloud. So the point is, with all that clever stuff and all those benefits, you don't need hydraulic models in this use case. You don't need network maps. It's all just about that single level sensor. So how can you get as much value from that as possible? So to illustrate practically what this looks like, here's a screenshot of the application. And you can see here in the single asset view that actually you've got the predicted level, the measured level, the rainfall. In the background, you've got the color of the AI classification, if it's healthy or if there's an alert and alarm. But also you can see beneath that time series data, you've got the actual spill count in there as well. So it's easy for different users to be able to understand what's happening to that asset as soon as possible. And then, of course, you've got some basic commenting down the bottom before it goes into a works management system. And then you can automatically produce your report around that asset if you want to. And this is a step towards, this then could link into a system level view, which I'll come to in a moment. But that's the whole point of getting multiple use cases and multiple value around that. And it's only if your data quality is good enough, can you then add that value in the organization. Third example. We've talked there about two use cases. If we then think about this on a system level, which is where we started, how can that same level sensor then also support optimization of the catchment view? So this is based on a project which we have in Germany, where you can see we optimize flows through the network to use the latent capacity of wet wells, storm tanks, and the network itself to actually reduce the spillages in the network. So you control pump operations and valves. So you can see here, based on the rainfall, you predict how much is coming into the catchment. You then optimize what you think your different routines could be. You then operate those different assets, and then you optimize that through your on-premise SCADA. But again, the critical thing within that is if you're using the latent capacity within your network to improve flows, again, it's all about level and flow sensors. So as well as using it for those pollution and EDM use cases, you also want to use it for the system optimization. And you can see here for this water company in Germany, it increased the volume of treated water by 19%, reduced the volume of discharges in heavy rain by 10%, and you can see a massive reduction in the volume of discharges in light rain. So again, it's about understanding, okay, if I'm going to have a sensor that's going to have to provide these multiple different functions, how do I actually do that? This is a more complicated, involved use case, and we're keen to work with UK water companies on this one too. So I'll conclude there. Our time is up, and I hope that's kind of set the scene a little bit for while SWIG, we rightly have a strong focus on sensors. As we look to the future, has been discussed in other events, it really is about how we are going to provide that foundation for system level integration and system optimization. And in the discussion, I'd be interested in your thoughts for what you see as the challenges as we look to do that. And Well, I haven't. I've lost. I cut the slide out. Why did I do that? So what we look to see on the 29th is we've got presentations from Joby Boxall from the University of Sheffield, who's looking at that systems level analysis as he coordinates that massive water research program within the UK. We have Tom Claydon from Northumbrian, who's talking about water quality and particularly how you manage and optimize the sensors to ensure you get the data quality throughout the whole technology stack. We've got Tom Rust from Anglian Water, who'll be there talking about the focus on value. And of course, I have some Siemens colleagues talking about how you can take advantage of the data that exists within a sensor at the moment anyway, and what's coming down the line to ensure actually you get as much value from it as possible. So I hope that was helpful and stimulated some thinking, and I'm looking forward to discussion.
Thank you, Adam. I'll turn on my... Now, Adam, you touched on my favorite subject of data quality. How do we do it properly? Because data quality, I think every intelligent system-based project I've seen that hasn't quite gone as well as it should have done has had the challenge of data quality. The technology is not it's not the fault of the sensor, despite people bringing up all sorts of suppliers and going, there's something wrong with your sensor.
Yeah.
How do we do better?
There's something massive about how it's installed and where it's installed. And I think, how can we as sensor manufacturers simplify that process? So for us, that's where that kind of automated over-the-air onboarding, linking that automatically in Analytics app, there's definitely something around that. There's also something when you do then find the problem, how do you know the root cause? There's a massive thing of saying, is it the comms? Is it actually the sensor? And I call it the sensor person, or actually is it something that's going to be related to the way it's been installed? So for us, looking at the echo confidence, we'd recommend bringing some of those variables from the heart register back. In our case, bring those back in the app. So then you can compare that and say, well, the sensor's fine because actually, the echo confidence remains good if it's a radar sensor, for example.
I've got 100% echo confidence.
It's not the sensor, so it's going to be this. So I've got comms, I've got strong echo confidence. So actually someone go to site because something's not right in where it's being installed, or it's not the sensor, or is wrapped around it. And you need to take those different things to the root cause.
I see this, to my mind, getting even more vital because we've all seen what's happening with EDMs, et cetera, at the minute. It's all going to become open data. I saw, a day or two ago, the amendment around publishing data within an hour, which scares the bejesus out of me, to be honest. Now we've all seen the various headlines, and now anyone who's in the industry will know that some of those spills are to do with data quality issues. So 400,000 spills or whatever it is, how much of that is data quality issues, how much of that is dry spilling, which obviously, and how much of that is storm spilling. Now, I know that's a discussion that's going to happen at WEM this year, but I love the systems approach. What other data can we bring in? We talked about a level sensor, and there's a lot you can get from that level sensor. But it's how can we get that to interact? And with the SWIG system, it looks fantastic. How can we take best advantage of that?
And I think there's a genuine question about how do you understand and map out the different use cases? And this is where the multiple user groups need to come in, which is to say, so for example, on water quality, which is another area where we work, actually it's really helpful to have flow, pressure, along with your water quality sensor data, because actually that helps you better understand what's happening within the network, and as you then trace the movement through the system of different issues. So actually, those water quality people need to be having those same conversations.
Great.
And I think there's multiple different examples of that, of cross-functional teams coming together to map out use cases.
To me, that's always been with the whole digital transformation piece is the mapping of the information needs, going from that top-down approach.
Yeah.
And
got to start off with the challenge and where the value lies in that challenge.
Exactly. Exactly. No, couldn't agree more on that, really. So rather than me dominating things, is there anyone else who wants to ask questions, or are myself and Adam just going to have a chat?
I think Andrew's put his hand up.
Yeah, Andrew Chappell's got his hand up. Oliver and Adam, yes. My point here, one of the main things about data quality is, yes, there are, and in the past there have been a lot of issues around sensors. I've tested enough of them to know that there can be problems with temperature, power supply, and all the rest of it. But in many cases, I think yourself, Adam, and manufacturers and your competitors have got a bit of a hand on that now. I think sensor quality has improved a lot over the last 10, 20 years. The other issue, I think, isn't much the positioning of a sensor. It's the location. It's whether it's in the right place to make the measurement you need. The best example, which is something we never talk about in water industry very much, is temperature measurement. Thermometers are stable. They have been stable, well characterized for donkey's years. Thermocouple tables are everywhere. PRTs, wonderful bits of kit. But if you put a thermometer in the wrong place, you're not going to get the bulk temperature measurement. You're going to measure the wall of the tank. Sometimes thermometers embedded in oxygen sensors, which I've seen in the past, don't measure the water temperature. They measure the temperature of the sensor. They measure the temperature of the oxygen, the plastic housing. Black housings with embedded temperature, with embedded thermometers, can read 30, 40 degrees when the water's only at 10, if you get them in sunshine. So it's guidance on location, it's guidance on avoiding other issues, I think, which needs to be included. I think suppliers, manufacturers need to give some hints and guidance to users, because there are many naive users out there who will stick something in the wrong place.
I know. I think the best version of that I've seen was a PT100 thermocouple, which was for flow measurement, stuck outside the side of the cabinet, literally getting a lovely point so somebody could fall on it. But yeah, I would agree, Andrew. We're lucky, in anyone who knows me and knows Andrew knows we're deeply involved in MCerts. I think we're lucky with MCerts, and I still see out in the world of things single braced level sensors that are just there wobbling, and you're just going, it's meant to be level, guys, come on, you're not allowed to wobble, it shouldn't wobble. So yeah, I must admit there is some guidance coming up on that. I'm actually writing the BS-SEN standard for ICA and wastewater, and there will be some guidance in there for users. I've got lambasted slightly by my German colleagues by saying it's a bit simple, but yeah, I would agree. I've insisted saying, yes, actually, I do want some simple stuff in there to guide people, so water companies can turn around to the contractors and say, well, in BS, blah, 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 it says you must do it this way.
Yeah, and I think valid, Andrew, around potentially suppliers and, some of those things that we might be able to say. So, yeah, point taken. Richard, I see you have your hand up as well.
Yeah, thank you, guys. Following on with what Andrew said, I've worked in the water industry for nearly 20 odd years. And one of the most frustrating things for me within the water industry, it's not the instrumentation. The instrumentation is fine. It works. It does what it says on the tin. You're right. It's the application, where it's mounted. And it's the frustration of the amount of times I've been called to a plant to have a look at a problem in my earlier days when I was doing those sort of things, was down to poor design and installation. And it still happens. I can be speaking to people, let's take sledge. Why would you put small bore pipework on sledge when you're monitoring, because all it does is cake up. But people put in live maintenance fittings, where it should be straight onto the flange. The instruments will last. They have very few moving parts. So going back to what Andrew said, the technology and the let's say the quality of the instruments has moved on so much that you don't need to adopt old practices, which is what's being used. And it's the most frustrating thing. So like you say about overspills, I've seen sludge tanks overfill because the small bore pipework is blocked up. The designers are inherently causing the problems by designing in faults.
And Richard, for me, this is the compounded risk kind of challenge, which is if actually the impact of what you do in there is relatively small because it's all localized, because everything is localized, then okay, it's rubbish, it's not good, it's not acceptable, but it has the limit in terms of its impact. But when you start then seeing that as part of a bigger system level view, and potentially might be making a decision based on what you think will happen at site or what you think is happening at site, and actually it's not for some poor design decision, that means either you're not getting a reading or getting an incorrect reading, or you then try and get that particular bit of kit to do something that it can't. That's then when I think your problem gets bigger and bigger. And that's the world we're coming to, I think.
Yeah, and there's nothing worse than sewage spillage. Nothing worse, even if it's an overflow or it's contained within the plant, it's still a health and safety issue, and that's down from poor design.
It is, and I think one of the things that we're talking about by talking about the systems approach, it brings the value of the sensor much more sharply into perspective. So I was speaking on a call about 2 weeks ago, and I actually turned around and said, look, I don't give a damn about the price of the sensor. I said, I'm going to be quite upfront about this. Realistically, the installation of the sensor, the value of that sensor is a lot more than the cost of that sensor is ever going to be. So realistically, when I was in a water company, if somebody had turned around to me and said, look, I've got this sensor that's going to sort out all your problems. It's going to be really cheap and easy to install. But bad news, it's 10 grand. And I know you're only paying 600 quid at the minute. I go, and this is where, in some ways, we need to catch up with Totex. What's the total cost of that installation? Because I can install a flume, install a 100 mil flume. It's going to cost me 20 grand. Sensor's 500 quid. The entire cost is going to cost, say, 30 grand in all. Okay, how long is my sensor going to last? 10 years. Great, fantastic, brilliant. That's all I need. My flume's going to last me 20 years if I'm lucky. There's my Totex. Now I've had one partial flow electromagnetic flow meter on a 1 meter channel. I think it was 35 grand for the sensor, 100 grand for the install. Okay, new technology I'm going to do. I could potentially use 15 grand. Brilliant. But actually, what's the value of that sensor? What's the value of that sensor being wrong? So I've had the situation where an operator's come around, fiddled with the flow meter, and it's reading 300% high. In some ways, great that it was reading 300% high, but the conclusion off the back of that initially was, we need a massive growth scheme. Oh, that's going to be £25 million.
But
based on the data of a £500 sensor.
Yeah, Oliver, I totally agree with what you're saying. But until we can change the mindsets of the design and delivery partners to looking at pounds, shillings, and pence, 20 quid on a sensor to them, they think it's enormous. The scale of their philosophy on this is totally wrong. Yeah. Sensors don't cost them money. It's the installs, the construction, it's everything else.
Yeah. Darren, you got your hand up.
Yeah, just sort of picking up on what Richard said there, and I think what we said today, and thanks Adam, I think it was a great talk. It's the value of being able to get more out of each sensor and taking in more than one application. And quite often I see, given sort of the example there, if you like, this is an EDM sensor, therefore it needs to be a low cost kind of budgetary type of maybe switch, even a level switch. This is being used for a different purpose, therefore we need to get something which has got a bit more accuracy, a bit more reliability, and it's about obviously it's about trying to meet those two needs, if you like, and spend a bit more money on the sensor, because actually if you did spend a bit of money on the sensor, then we will get that additional data quality, as Adam was talking about. So I'm interested really just to hear from, maybe open the question out to the group, but particularly perhaps to you, Oliver, where else can we see that additional value? So what other applications where we're spending money on a cheap sensor and then additional money on a more expensive sensor, that actually one sensor could serve both purposes?
I think Adam's 100% right on this. It's looking at that systems approach. I was sat at a table at the innovation conference, the WWT Innovation Conference, must be a couple of years ago now. And at the time they were going, right, we want to install 20 million sensors or whatever. We've seen various water companies publish things recently going, we're going to install 50,000 sensors. And you go, actually, guys, no, don't do it. Look at what actual information do you need to run your business. And don't go for the cheap. There was one water company I know through various sources. They installed 8,000 sensors in 8 months. And you're just going, don't do it, guys, because I can guarantee you the install quality on that is going to be terrible. Half those sensors aren't going to be working because you've installed them badly. And the rest you're probably never going to use. So really, and this comes to a piece that I wrote for the IWA actually on digital transformation and sensors. Know what you're going to use that data for. So, for example, we're all installing FFT monitors on wastewater treatment works. Regulatory requirement, brilliant piece of work. Guess what? What else is it used for? Well, when I was in a water company, we used that for pollution and blockage detection. When you look at some of the technologies out there, some of the artificial intelligence, machine learning technologies that are coming into use, they're predicting flows. Well, predicting flows, great, but actually we're now going to be measuring them. So how can we use that regulated flow monitor that we're measuring stuff for in a different way? Very easily. Now, that particular application, there's a quality requirement on the sensor. Fine. But what else can you use it for? And it's getting all, as Adam was saying earlier, it's getting all those linkages right. I years ago said, well, we've got to stop thinking about networks and treatment works. It's becoming more and more important. But also, I think we have to educate the public as to the value of doing something. We've seen the amendment at the minute is going to require monitoring up and downstream of an overflow. And okay, I can understand it from an environmental point of view, but what's the real value? And actually, you look at it and go, very little.
I think I agree. I think catchment level monitoring, I think, is going to be an interesting frontier based on the focus on end water quality in the watercourse. And I think the complexity of understanding what's coming from the different users around any river or lake, particularly with agriculture, I think as that focus moves from what's coming out of your network into what's the actual quality of the river, if I was a water company, I'd want to be able to say, I know what's coming from my system. Where's the rest of this coming from? And how do I ensure that actually the community's focus isn't just on me, but is on all those stakeholders that have an influence on that river or lake? And how we provide the data to allow people to do that will be, I think, something that's going to come up in the next few years.
Definitely. And in an open and honest way.
It'll all have to be open.
Yeah.
Agreed.
Yeah, can I just add to that? We did have a workshop on nutrient monitoring a year or two ago. I'm losing track of time now. And the Environment Agency are doing trials on catchment-based permitting, where you're looking at different inputs into the same catchment and kind of you can, I can't remember what they called it now. It's kind of flexible permitting. So you're kind of looking at all the different inputs and managing them as a whole rather than individually.
And that kind of fits towards the net zero goal as well in terms of efficiency. It really does, which is an interesting spin on it. So realistically, one of the how do we get the best value out of a sensor is look at the use. Are we going towards, dare I say it, the factory approach?
Which we also have a workshop coming up on.
We do.
Next year. I was going to say, I think SWIG has a role in all of this. I mean, we do need guidance, obviously, but at SWIG events, we talk about best practice on installation of sensors. So anyone who's interested in that subject, do come along to our events.
And of course, Rosa, we've got a nice training library, don't we?
Oh, yes, exactly. Yes, thanks for pointing that out. Yes. Actually, I've got a few slides. I was going to mention that as well. I'm just aware of time. Should we round that up now?
Yep.
Yeah. Otherwise, I think we'll waffle. I'll certainly waffle on for the next couple of days. So anyone who knows me will know that's true.
No one's got their hand up at the moment, so I think that might be the end of the question. So, hi, Andrew. Did you have something to say? No? Okay. Okay, well, thanks very much to Adam for that really interesting presentation, and thanks to Oliver as well for helping to chair the discussion session there. I've just got a couple of slides to go through before ending the Lunch and Learn today. And thanks again to Siemens for sponsoring this Lunch and Learn and the main event on the 29th. Just get the slides up for you.
So for those of you who aren't familiar, we do have an event on the 29th. Please do join us. Details on the SWIG website, and I'm sure Rose is about to bring it up. We will certainly continue the discussion there. So, yes, do join us.
Okay.
And in the meantime, Rosa.
Yeah, thanks, Oliver. So there's various ways to stay in touch with SWIG. And so our next webinar, I should say, is on the 29th on how to get the best value out of sensors. So we'll be going into a lot more detail and have presentations from a range of people at that webinar. Then in October, sort of following on the same theme in terms of how you can use your sensors the best way, we have communication and protocols. So again, that's quite a general webinar if you're using sensors. That might be of interest. And then November, we've got a sensor sprint, which will be quite an exciting event where we'll have presentations from water companies outlining their major challenges. I'll talk about that in a sec. And then we're looking for pitches from innovative companies with sensing solutions to the major challenges. The deadline for that's the 30th of September, but I'll go through that in a sec. And then into next year, we've got leakage, wastewater monitoring for epidemiology, nutrient monitoring again, and catchment monitoring. So just touching on that just now. I just wanted to mention briefly, we usually have an early career innovation prize every 2 years, but that got delayed by the pandemic, and that will coincide with WEM 2022. So watch this space. There'll be more details about that. There's some details on the website already, but we'll be launching the call for posters in early 2022. And we currently have a call for papers for our sensor sprint. So we're looking for solutions to these three major challenges: network flooding and water pollution, which we we're just talking about, achieving net zero carbon emissions, and leakage and per capita consumption. So there's details on our website about that if you're interested. And as Oliver mentioned, we do have a new training video library on our website. There's still a few gaps, so if anybody, as long as you're a SWIG member, you can send me links to your videos, and as long as they're informative videos, I can include those in the library, which is open to anyone. It's publicly available, so we're hoping that will become a really useful go-to resource for training videos on how to install sensors and to use them and maintain them, and just generally look after your sensors and get the best out of them. And thanks again for joining us today. If you want to learn more, then just scan this QR code and that will take you to the webpage where you can learn more about the webinar on the 29th, and there's a link there to the booking form. And thanks again.
And of course, Rosa, it's all available on the SWIG website, which you've provided a nice handy link for there.
Yeah. Thanks, everybody.
Thanks, everyone. Hope you enjoyed it. Hope to see you all on the 29th. Thank you, Adam.
Yeah. Thank you, guys.
Thanks very much. Thanks, Adam. Stimulating to talk.
Fine.
Thanks.
Cheers. Thank you. I'll end the presentation now.
Thank you.
Bye-bye.
Bye.